Hey, hello guys and welcome to Extreme Graphics Tech. My name is Angelo. I want to make this quick video talking about the new product that Nvidia is releasing in terms of software, a new software development that is going to help everyone with an RTX GPU, in this case called Nvidia Dlss 3.5, which is getting a little bit confusing, because you are going to have the whole number is starting to make things a little bit confusing, and the reason I'm saying that is because 3.5, as we know, the DLSS 3 is the one that has frame generation, then we have DLSS 2, which is super resolution, but now 3.5 is like AI ray tracing reconstruction. And what makes this confusing is the fact that any GPU from 3000 series to 2000 and 3000 in this case series don't support frame generation with its DLSS 3, but it does support Nvidia Reconstruction, which is 3.5. So you have DLSS 2 but not 3, but do 3.5. So it's getting quite confusing in the way Nvidia is making these numbers here. However, let's just talk about what this is, what it brings to the table, and why it's so interesting. So DLSS 3.5 is another step in Nvidia using AI to improve graphics. And before we enter into what exactly is DLSS 3.5, I have to say that many people seems to get angry at the fact that all frame generation, DLSS super resolution, and all these things, they are not real pixels. I have to say that the concept of real pixels doesn't exist. The pixel of what you see on a screen is whatever even the developer decided when they were making the game. So if you mean real pixel by what the developer intended, then they are using and implementing DLSS and frame generation into their game. So obviously that's an intention for you to use, because at the end of the day, the pixel can be whatever the developer wants, whatever the output of the software you're using want it to be. So if you are seeing the sun, they can make it purple. Does it make it fake or real is what the developer's intention is. So I am one that says that I don't care what the developer, who or how the pixel is created, as long as it's logical and is supposed to be where it's supposed to be. For all I care, all graphics can be created by AI, as long as what I'm seeing is what I'm supposed to see. And I think this is important because graphics are getting more and more expensive in terms of power, and we need ways faster and more intelligent ways to create those graphics if we want to keep advancing without having to spend thousands of pounds or dollars or whatever your currency is. And we are already expending that because GPUs are very expensive. So we need to take more advantage of all these techniques. So having said that, so DLSS 3.5 basically introduces what is called as a reconstruction of enhanced ray tracing AI. So this is the video that Nvidia put yesterday out, where they talk a little bit about what they have achieved so far, and then we have this sort of explanation in here. So basically what is here is the game creates or generates the geometry and everything, then is the light part that is the more complicated one. That's the part that is taking more computational power at the moment, because it's the more intensive, and that's where ray tracing comes in, and which we know is very computational intensive. So we have, for example, reflections and diffuse global illumination in this example. And what happens is that because you need to generate rays to create the reflections and to calculate the illumination when we're talking about ray tracing, the more resolution you have, the more rays you need to execute in order to get that. But obviously, even at 1080p, generating 2 million rays is a very expensive proposition. So what they do is that they don't actually do all the rays. They start, trying to take some samples from different places and trying to reconstruct the image from there, from the information that we get. This is very noisy image, but that from that information the GPU can reconstruct what is supposed to look like. So even in this case, even without using the DLSS, without using anything, we are guessing pixels basically. So as you can see, there are nothing like real pixel. At the end of the day, is everything or most of it an approximation. So what happens is that when you create images like this, then you need to use something like a denoiser, which is to obviously remove all the noise that is created, because in many cases what happens is that there is accumulation of pixels between frames. That means that this computer, the game is going to take information from previous pixels to so it's accumulating information. But what happens with that is that it can introduce ghosting. I don't know if that's, I don't remember. So this is what I was saying. So you generate this image, right, which is all the geometries there and everything, but the light calculation is done in an approximation, because obviously you cannot send all the rays needed in fast time to get it real time. So with this information, the GPU then start using the denoiser and start to understand and infer what the image should look like in terms of lighting, and then it produces the final image. I don't know if it's shown here or not, but well, that's let's go ahead. So here, so as you can see, this is using a spatial and temporal accumulation, just trying to understand how the pixels around one image look and one part of the image, in order for it to reconstruct the image that is going to be shown. This process obviously introduces a lot of problems, because it's noisy and it's an interpretation and trying to get as much information as possible from that and reconstruct, and because it's bringing information from previous pixels, there is going to be a loss in detail in the cases of the denoiser, because obviously you can reconstruct perfectly from this sort of noise. But also it's going to introduce other artifacts like ghosting. I think it's shown here at some point. Let me see if I can find it. So here, so you can see it's introducing ghosting, and the reason it's introducing ghosting is because since it's using temporal information, I mean previous frames, then the image is created by using information from previous frames, and sometimes for the system it's hard to understand if something belongs or not to this frame, or if it was part, because it can know all of these details. So as you can see here, so that's why ghosting is created. So the DLSS has become better and better to try to understand that by the information given to with the developers when they're implementing it, but it's never going to be perfect. So the same thing happened when we're talking about global illumination, according to what the guy is explaining here, right? In this case, because of the denoiser, where sometimes you get some details away. In this case, this is what happened. You can see there is a shadow here that is not present here, but finally we have this here that I was saying, the denoiser is taking details out of the image, because obviously when you get only a few pixels and you have to try to reconstruct from that, you're never gonna get it perfect, because you are trying to make the image as clear as possible. It's quite good, but it's not perfect. So with Dlss 3.5, and let's go ahead to at some point where Nvidia there is more information. What is happening is that this DLSS 3.5 has been trained in 5 times more data than it was even used for DLSS 3, which is the frame generation, to understand how to basically denoise the image. It's not denoising it other than reconstructing it, because it has a lot of data to understand how to interpret this sort of information. So instead of denoising it like we know in traditional way, what it's doing is actually reconstructing it by image, because it understands how this here should be represented. So that at the end of the day creates a much better and pleasing image than denoising, because AI is much more intelligent than just a denoising algorithm. And so basically what DLSS 3.5 brings to the table is a different way to take that noise image and make it a full image. So instead of using a denoiser, you used DLSS 3.5, and the image will be converted from that noisy thing to something obviously more true to what it's supposed to be like. So here is an example that they have used. Let's see, because there are a couple of other examples where it's more clear. And as you can see here, this is the part that is quite interesting. So on traditional denoiser, because you are getting the reflections from what's happening above outside the screen, so because there is no many pixels to actually create what is supposed to be there, so this is the results, which they look quite good. And obviously, because we don't know exactly how a reflection needs to look, for us it's convincing. But when you use AI to reconstruct, the AI uses a much better approximation, because it knows, it's been trained to understand how to interpret those pixels. Sometimes I get between Spanish and English and it gets a little bit weird for me. So essentially, this is what is happening. So it's important to understand that this new DLSS 3.5 is not about performance in the sense of giving people more performance. However, there has been like a sub situation. You can see here, once again, this is the image. This is an image that has been, just rendered by a software. It's not a game, it's been rendered as a preview, so something very fast, just to have an idea before you actually commit to render, because it will take a long time to render. So this gives you an idea. However, when you use DLSS 3.5 in the same software, in this case it's called D5 render, you can see that the approximation is much better, even if it's a preview. Because using AI, it sort of understand better how to take this image to this one, instead of using a denoiser that is going to create more, not a quite good image. So this is not about performance, as I said, and I think they mentioned it around here. Let's go here. So as you can see here, however, they are getting some extra performance, and the reason of that is because a denoising, when a normal denoiser, is much slower than just using 3.5, that DLSS RT reconstruction. So this is the reason why it's getting some FPS. But of course, this is not what they're aiming at here. It's not about having more performance, because depending on the denoiser you're using, it could get worse and worse. Sorry. So as I was saying, so this is not about performance, but because the denoising, depending on the quality of the denoiser you are using, could be very heavy, then using AI seems to be faster, and this is like a sub-product of using the DLSS 3.5. But it's not something that is guaranteed to happen in every game, because maybe a game is using a very cheap or very fast denoiser that is not going to give any advantage over 3.5 in terms of performance. So at the end of the day, they could be the same performance, but the end result is that using 3.5 DLSS is going to be a much better and pleasing image than it was on the other version of the software. And I understand from what they said that there is 2 games that at least announced that are already confirmed to be using DLSS 3.5, and that is going to be Cyberpunk, the new Cyberpunk expansion, that I suppose is going to be on the normal one when it releases in September. We are going to have this included in that version of Cyberpunk, but also on the next Alan Wake 2 game that is going to be completely path traced the same as Cyberpunk 2077, which is going to be really insane if that's the case. With all this technology, it must look really amazing, and we're going to have another very AAA game going completely path traced. So in this case, Nvidia is doing a very good job at just improving things in terms of ray tracing and making it every time even better and more usable for everyone. As I was saying before, DLSS 3.5 is part of RTX 2000 and 3000, so you are going to have the benefit of DLSS 3.5, but you are not going to have the benefits of DLSS 3, which is the frame generation that is still only available for RTX 4000 series. However, DLSS Super Resolution, DLSS 3.5 AI Reconstruction is going to be part of everything. So the only thing out at the moment of the previous series of RTX is the frame generation. So yeah, it's a little bit weird because you see at the end in this graphic you can see that they turn on DLSS 3 in this case, which is FG at the end, which is super resolution plus frame generation, but the frame generation is not part of that. But then you can turn on DLSS 3.5, which is part of RTX 2000 and 3000. So it's a little bit weird that you can go up to 3.5 by skipping 3 essentially, because 3 is not part. So it's a very confusing. So they said that all of these things together will give you a much better image quality. So there you go. Nvidia improving things with DLSS. It seems awesome, and I cannot wait to see it myself and to test it on a new and different game like Alan Wake 2. Hope you liked this video. It was give you the information you needed to understand it better. And yeah, thank you very much, and see you on the next video.